Okay, I'm going to show you how to parameterize some lines and, whoa, oops, there we go. Alright, parameterizing lines. Okay, so basically they're gonna, I've drawn out L, okay, and they'll give you like a line, a point on it, then they'll give you a vector that's parallel, okay, and they'll ask you to, make an equation out of it, okay, and this is really, you have to be able to do this stuff. So first of all, let's see if we can't define the line segment PX as a vector, and see here, that will be, looks like x minus 2, y minus 1, and z minus 3. Did it fit on the page? Yes, okay. Alright, so we got that, alright. Now notice how if vector v is parallel to this whole line, it's certainly parallel to px. So we can go ahead and state that vector v is in fact parallel to vector vx. Now, they aren't equal, however, okay? But we are going to make that happen. So let's say we want them to be equal, okay? If we want them to be equal, I need to introduce a scalar multiple that's going to make that happen, okay? So I'm going to say TV is equal to PX, okay? So if I take t and I multiply it back from my scalar multiplication video, if I take t and multiply it by vector v, well, what's it going to equal? I'm running off the page, of course. So 2t, 4t minus 2t. Okay, it's just distributive, okay? And that is equal to, looks like x minus 2, y minus 1, z minus 3. Okay, well, since they're all equal to each other, I can go ahead and start doing my what's called parameterization. Okay, so I'm going to take, we're going to say 2t is equal to x minus 2, 4t is therefore equal to y minus 1, and negative 2t is equal to our third component here. So for the first one, 2t is equal to x minus 3. 4t is equal to y minus 1. Negative 2t is equal to z minus 3. Just like that, okay? And furthermore, if I wanted to get a little fancy, I guess I could always solve for x. So we get x equals 2t plus 3. Y, that's going to be, what, 4t plus 1. Z is going to be equal to negative 2t plus 3, okay? And notice how all these are going to be your parametric equations of this line right here, okay? So just going back through here, originally, they just gave us a point and a vector that was parallel to the line that went through the point, okay? So that was given to us. The not so obvious thing is that, you need to introduce sort of just like an arbitrary point. When I say arbitrary, I mean, all we're going to do is say that there is another point on, it's a line. It takes 2 points to define a line, so we don't know what that other point is. And there's infinitely many points on this line. We could have chose any of them, so we just choose a point. We leave it in terms of variables, okay? Because the variable is going to be determined by the parameter t, okay? So those definitely look like parametric equations. If you cover this one up, just like back from a little earlier on, I'm sure you guys have at least seen them a couple times before. So that's basically how we go, okay? So we roll. All right, have a good one, and I will see. Well, do I need to do another one? Maybe we'll do some examples in the next video, okay? That's all you do right there, okay? All right, have a good one, and thanks for watching my videos.